Welcome to the class of Inorganic Chemistry. In this course, we are going to cover all the inorganic compounds and their properties, behavior, and characteristics. But before jumping to the inorganic compounds, we have few main branches of chemistry, which are organic chemistry, inorganic chemistry, physical chemistry, biochemistry, and analytical chemistry. Organic chemistry is the domain of chemistry which includes or deals with hydrocarbon. Specifically, these compounds are extracted from living beings. That could be human, that could be plant, or any other animal. Whereas inorganic chemistry is the domain of chemistry in which we have non hydrocarbon compounds. Mostly, we deal with the metallic compounds or minerals in inorganic chemistry domain. Next is we have physical chemistry. Physical chemistry is a branch of chemistry which deals with all the practical application of chemistry in either thermodynamics, in chemical kinetics, in photochemistry, in electrochemistry, in material chemistry, or biophysical chemistry. So, physical chemistry is basically the application of chemistry in different domains. Next is your biochemistry. Biochemistry, as the name indicates, is it is the chemistry related to life, life of plant, life of animal, life of human being. Last is your analytical chemistry. Analytical chemistry is the branch or domain of chemistry which is specifically deals with the scientific and technological processes used in your electronic devices, semiconductors, and all that. Okay. Next is the difference between the organic compounds and inorganic compounds. As we have just discussed that organic compounds contain hydrocarbon molecules, so they must contain carbon atoms. They contain carbon and hydrogen atoms in uh, combination with nitrogen, oxygen, sulfur, phosphorus, and more. The name includes the bond formation or the compounds includes the formaldehydes, glucose, cellulose, and many more. However, in inorganic chemistry, we may have or may not have carbon compounds, carbon atoms, in combination with sodium, oxygen, calcium, because these are the compounds form or molecules are not present with carbon. These include salt, NaCl, your acid base reactions. These are all covered in inorganic compounds or inorganic chemistry. However, both of them, the inorganic chemistry or compounds or organic chemistry or compound, their combinations are present in a living organism because living organism is a complete package of all the branches of science that could be electrical, that could be mechanical, your central nervous system as a controlling system. Likewise, in at chemical level, at chemical composition level, human body or any living organism contains both inorganic and organic compounds. Organic compounds in the form of lipid profiles, in the form of protein molecules, in the form of glucose, fatty acids, or inorganic compounds in contrast found in the form of minerals and oxides. So the question is, what is inorganic chemistry? Inorganic chemistry is concerned with the properties and behavior of inorganic compounds composed of matter other than plants or animals, or they are not driven from living matter like and includes metal, minerals, and organometallic compounds, which cannot be extracted or driven by from living matter. While organic chemistry is the study of carbon containing compounds and the extract obtained from living organisms. Next is the classification of compounds. As we have organic and inorganic two domains, two opposite domains, but in both of the domains, we do have both naturally occurring organic compounds, naturally occurring inorganic compounds, and synthetic organic and synthetic inorganic compounds. Naturally occurring organic compounds are mostly natural polymers that includes polysaccharides, cellulose, chitin, chitosan, agar, proteins. In proteins, you have collagen, albumin, and carbon compounds. Whereas in synthetic polymers, we do have polystyrene, polymers, polyacrylate, polyvinyls, and more. However, in inorganic compounds, those which are present in natural minerals, we have clay, kaolin, slate, silica, and more. In synthetic form, we have glass beads, metals, and metals oxides. Now, again, few comparison among inorganic and organic chemistry. Inorganic chemistry deals with inorganic compounds, typically those that have an ionic basis or ionic bond formation. However, in inorganic chemistry, the compounds deal with uh, hydrocarbon compounds mostly. Inorganic includes acid base reactions, displacement reactions, redox reactions, whereas organic compounds includes these reactions depend on the functional group present on the compound. Inorganic compounds mainly deal with salts and crystals, whereas organic compounds deals with oils, fats, sugar, lipid, etc. They have higher melting point and degrade instead of boiling. After melting, they don't go for boiling reactions, rather they degrade. Whereas organic compounds melt as well as boil easily. Where is inorganic chemistry used for? Inorganic compounds are used as catalysts in the form of pigments, for coating, surfactants, in medicines, for fuel purposes, and much more. They often have high melting points and specific high or low electrical conductivity. Electrical conduction properties of inorganic compounds are very good, which make them useful for certain specific purposes, including ammonia, which is a nitrogen source in fertilizer. A very good source for fertilizer is ammonia. It is one of the major inorganic chemical used in the production of nylons, as well fibers, plastics, polyurethanes, hydrazines for jet and rocket fuels, and explosives. So ammonia is not only used for fertilizers, but it has a lots and lots of other applications. Chlorine is used in the manufacture of PVC pipes, polyvinyl chloride for clothing, furniture purposes. In agrochemicals, again in fertilizer, chlorine is being used for insecticides, soil treatment, pharmaceuticals, and chemicals for water treatment and sterilization. Chlorine is the best uh, water treatment. It is used to clean the water. Next is titanium dioxide. It is the naturally occurring oxide of titanium, which is used as a white powder pigment in paints for coating, plastics, paper, ink, fiber, food, and cosmetics. It also has good ultraviolet light resistive properties, and there is a growing demand for its use in polycatalysts. Polycatalysts are used in especially the domain of physical chemistry. Next is periods versus group in your periodic table, tabular form. Okay, so the difference between periods and groups are differentiated on different levels. For example, on the basis of location, periods are defined in horizontal rows in the periodic table, whereas groups are the vertical columns of periodic table. Numbers, there are 7 periods on periodic table. However, there are 18 groups in a periodic table because you have 7 periods, 7 number of rows in periodic table, which defines the periods of that table, whereas groups are in 18 number of columns. Next is electronegativity. Electronegative properties increases from left towards right, whereas in groups, it increases from bottom to top. So at the right top side of periodic table, you have good electronegative properties found in the elements present at right top side of the periodic table. Next is characteristics. Elements within the same period have same electron configurations, whereas elements within the same group have chemical or physical properties. They have the same number of valence electrons. Another similarity among the periods is that they have the same number of electron shells. So how many number of shells are present? That defines or described by the period of that um, element. For instance, lithium is second period. So the number of electron shells found in lithium are 2, whereas in sodium, the number of shells present in sodium atom are 3. As same goes with magnesium. For magnesium, magnesium has 3 number of electron shells. Likewise, in case of groups, the elements in the same group have the same number of valence electrons. So for instance, lithium is present in group 1. So lithium has 1 valence electron in its outermost shell. Likewise, sodium has 1 outermost electron in its outermost shell. And krypton also has 1 outermost electron, 1 electron, valence electron in its outermost shell. It This slide describes the difference between the mass number and the atomic number. Mass number is the total sum of number of neutrons and protons. That how many number of neutrons and protons are present in nucleus of any atom describe its mass number. Mass number always written and or found at the left top corner of any element, whereas the left bottom corner describes the atomic number of that element. For example, for helium, it's 2, which means that helium has 2 proton found in its nucleus. Moreover, this number let us know how many protons are there in the neutral atom. This is also the same as the number of electrons. As far as the atom is not going or not making any bond, either the covalent or ionic bond, the electron remains in a stable state and the number of electron is equivalent to the number of proton in any stable atom. Okay, here are two examples. One is of oxygen and another one is of neon. Neon is found is a noble gas column of last column of periodic table, which is also known as the noble gases. So neon is a noble gas. So oxygen has 8 electrons. It means the first shell contain and fill up with its maximum capacity of 2 electrons. So the rest of the 6 electrons are found or present in its outermost shell, which is the second shell. However, the second shell has capacity to contain 8 electrons. So 2 vacant spaces are still present in its outermost shell of oxygen. 6 valence electrons are present, whereas 2 electrons are can the oxygen has capacity to gain 2 more electrons to complete its outermost shell, and which makes the oxygen atom a reactive atom to react or make bond formation with other atoms. Whereas in neons, it has 12 atomic number. It means it has 12 electrons. So, as per their number of shells, first shell is containing 2 electrons due to its maximum capacity of 2 electrons. And the next shell, which is shell number 2, has 8 electrons according to its maximum capacity. So its outermost shell cannot gain any further electron, and due to its completely filled outermost shell, it can neither be lose any of its electron. That is why it has 8 valence electron in second shell, which has a capacity to contain maximum of 8 electron. This is categorized in noble gas as a non-reactive element. Next is your bonding or the types of bonding. What is mean by bonding? You have chemical bonding. Chemical bond is a force of attraction that tie or holds atom together to make compounds or molecules. Bonds are formed when valence electrons interact each other. The nature of interaction between the atom depends upon their relative electronegativity. Electronegativity defines which type of bonding interaction is going to be formed between two atoms or molecules. These bonds include strong intramolecular interactions such as covalent, polar covalent, or ionic bonds. However, the molecules are also interrelated with weaker intermolecular forces such as dipole-dipole interaction, the London dispersion force, and hydrogen bonding. So you have intramolecular forces, which are found the atoms of a molecule, which are found among the atoms of a molecule, whereas intermolecular force, which are weak, are found amongst the molecule or in between the molecules. So intramolecular forces are basically good bonding forces, whereas intermolecular forces are weak or non-bonding forces. Intramolecular forces are found within the molecules, whereas intermolecular forces are found among or between the molecules. Intramolecular forces influence the chemical properties of a compound. They alter or vary the chemical properties of any compound. Sorry. Whereas intermolecular forces influence the physical properties of any substance, and they contribute in structure formation of any substance. The intermolecular forces and arrangement due to the intermolecular forces describe any physical structure of that substance, molecule, or compound. Intramolecular forces includes your metallic bonds, ionic bonds, covalent bond, whereas the examples of intermolecular forces includes dipole-dipole forces, hydrogen bond, etc. Next is electronegativity. Electronegativity is basically the tendency of any atom in a molecule to attract the shared pair of electron towards itself or towards the nucleus. How much nucleus has capability to attract the electron of next atom, or the atom which is going to be pair up with that first atom. So the tendency of any atom to attract the electron of next atom is known as its electronegativity. Just because it is a tendency to attract an electron, it is a dimensionless or unitless property, because this is only describes the tendency. It indicates the net results of tendency of atom in different elements to attract the bond forming electron pairs. We measure electronegativity on several scales. The most commonly used scale was designed by Louis Pauling. According to his scale, fluorine is the most electronegative element with a value of 4, whereas cesium is the least electronegative element with the value of 0.7. Your electronegativity increases from left towards right, whereas electronegativity decreases from top to bottom, or vice versa, it increases from bottom to top. Fluorine is the element which has greatest electronegativity. Noble gases do not have electronegativity properties because they are non-reactive gases, whereas all the other elements found in periodic table are stable, although stable in themselves, but they have valence electrons and they have capacity to make ionic or either covalent bond formation. So they have electronegative values. They have their own electronegative values to attract a shared pair of electron. A low electronegative value completely doesn't describes that it has an electronegative value of 0, but it means in comparison to other molecule, for example, if we are talking about the cesium, it has the least electronegative value of 0.7. 0.7 in comparison to other elements found in periodic table, right? So it completely doesn't mean that the least electronegative element does not have electronegativity or its electronegativity is 0. It completely doesn't mean. It means it has the lowest tendency to attract shared pair of electron. So this is end of the lecture. Hopefully everything is clear to you. See you in the next lecture. Thank you.